Nice to see you. How are you?
I haven't seen you in a long time.
Yes, it's been a long time.
You've been off. You've been on sabbatical, right? Yes. It's really nice.
Yeah, I was nice. I was 3 months in a row.
Okay.
Came back from that.
Did your wife go with you? Or?
Yes.
Very nice. It was fun. So now you're back to this semester. Is your first
Yeah.
semester back?
Usually in PC coming back.
Yeah.
So I still have a lot of commitments. And now I'm taking back to been here doing administrative work. We should have like a never relaxing sabbatical. Like, I don't know. I'm so sorry for you. I'm so sorry for you. I feel sorry for you. I'm sorry. I give you a sabbatical. No, but in my case, yeah. Well, there was one guy, he took 1 year from he took 1 year from Penny. He got a grant from the Getty Foundation. I didn't know you could do that. I don't know if I would have.
You were at the Gettys in those wildfires, did they? Out of your point, you were there with the fires.
No. Well, I met some people that
Speaking something to that area, right?
well,
Maybe not.
well, this last time it almost reached the Getty Center. So this infrastructure that these companies, it's crazy that in the United States these things happen. Like a company goes bankrupt and they don't maintain the infrastructure and they can burn the city.
America these days is probably
Hey, morning everyone. So, good morning, everyone. So, welcome to the 5th Heritage Engineering Forum. My name is Mario Santana. I am the director of the program, and I have the pleasure and opportunity to introduce you to Professor Amir Haqqani, who is the Associate Dean Research from the Faculty of Engineering and Design at Khartoum University. Amir.
Thank you very much. I think the pleasure is, of course, all mine because this is, I was just chatting with some of, for taking the time and some of you traveled here, some from not very far away, some from quite far where I think rather than snow or ice, fire is what is on people's mind. But thanks for taking the time and coming here. Nonetheless, it's also very nice for me to just say a few words because I'm in the same department as Mario. So I have in the past few years, I've been getting this steady stream of news and success stories, etc. But with Mario and his colleagues, as part of this CREATE program, have been able to do, and it always really amused and infused me. Because the mix is so unique and so interesting. As Mario mentioned, I'm here in my capacity as the Associate Dean for Research at the Faculty of Engineering and Design at Carleton. And just speaking in that capacity, I think one perspective that I'd like to share is the fact that Carleton is in unique or maybe less common situation of having engineering and the schools of architecture and urbanism as well as industrial design in the same faculty. And over the past couple of years that I've been in this position, I think I've come to recognize and appreciate how valuable that is to actually have those two groups being in the same, at least being forced to be in the same room, like here, but also in the larger campus and the larger faculty together. And I think this CREATE program is a really good example of that, of how we can bring both the artistic side and the technical side of perspectives as part of the spectrum into the discussion. And I think more importantly, not even a linear spectrum that is from here to there, more like a circle, that these two ends actually come together and work together. And I think if I wanted to think about one example of coming together, thinking together from different perspectives and disciplines, this really would be it. So I think it's very easy to say that you guys have accomplished a lot. You have trained a new breed of students or a new cohort of students. You have helped them develop really unique and interdisciplinary skill set. And I think it's one of those CREATE programs that you can actually say that has made a change that would last into future generations. I think you have a packed program. I don't want to take your time too much, but I also want to thank those of you at Carleton who are hosting this, particularly the students. You'll hear from them quite a bit, but it's important to note that you guys are really the main purpose and main product and main participants of this project. So thank you very much. I hope you enjoy your forum as well as what you have planned for the tomorrow's one. I think. Thank you.
Thank you, Amir. Thank you for your kind words and support to the program. So I have about 20 minutes to talk to you about the program. I don't think I'm going to quite speak for 20 minutes, although I have a lot to say, because basically after 4 years and a half, let's say, coordinating this program, there is a lot to talk about. And I think that that's one of the positive issues of this program, that we have a lot of experiences that has been accomplished, a lot of collaborations that has been established, and collaborations from different sectors dealing with heritage conservation and from people that usually don't work on the heritage sector. But before I start my presentation, I would like to thank, first of all, my colleagues, co-applicants to this program, and you will be meeting them. For those of you that don't know the program very well, you will be meeting some of them because they're going to be the moderators this morning and this afternoon. I would also especially want to thank Stephen Fay, who is my colleague at SIMS, the director of the SIMS lab, because he has given us the support to carry out all the activities that we can with the program. Certainly, Laurie Smith. I think Laurie is not here now. She's probably sending some email. We are going to live stream the event. So I think Laurie was sending the email with the link of the live stream. And certainly for this particular occasion, we got support from other of our cohort of creative students. So Michelle Duon and Renee Hell were helping us to set up today's event and tomorrow. Tomorrow we have a follow-up event. It's a workshop. For those of you that don't know about the workshop, you can come to me later. We have a lot of people attending the workshop, and as we have a lot of people attending today. So basically we have about 15 internships that will be reported this morning and this afternoon. And we have a keynote speaker also among us, Jeff Cody from the Getty Conservation Institute. He's going to talk about something to do with modern heritage, I believe.
You're right.
And I'm sure that you're going to enjoy Jeff's presentation very much. I have known Jeff for quite some time, and I always enjoy talking to Jeff or listening to Jeff. And at the end of the fourth panel, we are going to talk a bit about some research output that has been generated in the program. And we're going to talk about ethics. Although I'm not a very ethical person, I'm going to talk about ethics. I think that's the way it happens usually. No? All right, so up to now, we have basically supported 2 postdoctoral fellows, 40 master students, and 30 undergrad students. Now, the program doesn't finance undergrad students, but we have been giving the opportunity to undergrad students to participate in our activities. For the rest of the researchers, we have provided support not only for them to conduct their research, but also to conduct internships in Canada and overseas. Ongoing, we have about 8 researchers that are ongoing with their work. I have put expected and a date expected. I don't want to put anybody on the spotlight, but we want you to finish your degree before we finish the program. We have 2 more years of let's say 18 months of program. So you really need to make it to that stage, please. But of course, they have a very interesting research, so that's why it's taking so long. This year we had a graduating cohort of 4 people, Rima Watt, Abu Danda, Christian Falkhar. You're going to listen to Abu and Christian this morning. Unfortunately, Rim is out overseas working for a SIMS project with the Getty Conservation Institute in Paphos, in Cyprus. And Dr. Eric Costamagna, who was a postdoctoral fellow from Italy, returned to his country early this year. So we have also a cohort of our last cohort of students for the next 2 years. So we have Etienne, and you're going to be, where is Etienne? There is Etienne. Michelle is actually also a teaching assistant in my course, and she's helping some students now. So she will be here sooner. Fried. Okay, and well, Renee is also with the students, working with them. They are very committed, as you can see. Robin, Elise, Luke, and Natalie Smith, and actually Kevin. Where is Kevin? I don't know why it's not in Kevin Complido. I think I did miss it in my list, but I don't see it. Is Kevin here? Anyway, you're going to listen to all of them this morning. Kevin is very engaged. Yes, he's probably doing something for the program. So I'm quite happy also to see, and you probably will see some of our alumni working here and there, especially in Center Block. I think we have a number of our students working in Center Block, and then we have some people that have provided opportunities in Center Block. But actually, as we are speaking now, Raluca Drovenescu, who is one of the alumni of our project, is working for the Department of Tourism and Culture in Abu Dhabi. She's working on one project of Carleton University in which we are preparing guidelines, standards, guidelines, and protocols for documentation. And she's joined by a group of experts, also Anna is from SIMS, and Ona Vilekis is one of a postdoctoral fellow here at Carleton University. And then here you can see this photo is actually from yesterday, and Rin is checking some of the drawings that we produce after mapping the Paphos archaeological site for the Getty Conservation Institute. And next to her is Maria Luigi. Luigi is a professor from Politecnico that has also been collaborating a lot with our CREATE program. And Maria works for the Department of Antiquities in Cyprus. So you can see that our alumni is quite busy, and there will be much more images about them. This is my own project, but I wanted to show some images of some of our students, Mikel and Abu, working in Paphos this last summer, where basically what is really cool about the CREATE program is that we have been able to kind of take advantage of the knowledge that has been generated by research, and we have been able to apply it in specific projects with other partners. And I think that that's something that is really interesting. And I wanted to show you this small video. This is also from the Getty Conservation Institute project in Paphos with the Department of Antiquities. And what you see here is basically recording a mosaic, a exposed mosaic in Paphos. Paphos is a World Heritage Site. And basically, I think it's a little bit too bright, but this is a time lapse, and we are recording using photogrammetry. And we are working in the night because the light conditions, there is no light condition. So we use diffuse flashes to actually develop this. And this approach has been developed by several of our students in the cohort of researchers at CREATE. And I have been able to capitalize on that knowledge to be able to produce something more efficient and more coherent about mapping the most ancient mosaics. And I'm sure that as you hear throughout this morning and this afternoon, you're going to see that many of you, partner organizations in the program, have capitalized on that knowledge too. And unfortunately, even though I have been giving you all this good news, there is also a little bit of bad news. The program is going to end in 2021, and there will be no follow-up. I mean, there's no NSERC Create is a program that is established for 5 years, and after 5 years, it ends. There's no extension. Now, there are other funding schemas in research funding agencies. The Department of Civil and Environmental Engineering, where I teach, we have launched a new program called Building Engineering, and we have concentration, conservation, sustainability or performance, and fire safety. And this program will be, if everything, the Ontario government has changed a little bit, if everything goes fine, this program might be in place in 2 years. And this is actually one of the outcomes of the Heritage Engineering program, to create a graduate program in which people can continue participating. Now, we won't have the same level of support, but still we have created a critical mass of students that can have internships in companies. And I think that that's in companies and organizations, and I hope that we will continue this from all the co-applicants of the program, because we have established this type of collaborations. Now, if you have other brilliant ideas about how we can find funding, I am all ears. And of course, in Canada, there are many other types of initiatives. This is actually another video, and this is another project in which we have capitalized on the knowledge of our students. The ANCA project was financed by Arcadia Foundation, and it was conducted in collaboration with ICOMOS International, SCI-Arc, the University of Yale, and basically the Director General of Antiquities in Syria. And what we have created is a portal with information about 6 sites in Syria that were recorded by the Department of Antiquities after a training conducted by SCI-Arc. And after the training, the data was provided to SIMS, and we produced the portal, and we also produce a kind of repository with the library, with Carton Library, called Dataverse, in which people can download the data for free, but with the prerequisite that the data will not be used for anything than academic research. And this project was really praised by Arcadia, and it was a very successful endeavor. Now, some follow-up proposals. So we are considering some other funding agencies. The fundings will be different because they will be the funding that we have been considering don't deal directly with training. They deal mostly with research and partnerships with companies. But NSERC has launched a new initiative in which you can partner with organizations, private organizations and not-for-profit, and you get a level of support from the organization, given that you have a very kind of dedicated topic, and that falls into the engineering and sciences area. In January, we are proposing an ethics workshop that I will be organizing. It's on the second week of January. We are proposing to have a technical workshop on conservation of 20th century architecture, probably in the spring. We are proposing to have 2. Usually, we should only have funding for 1 forum, but we want to do 2. We actually want to do 1 on the fall of 2020, and then in spring 2021, we want to make a big closing event, like a big party, let's say. And given that I am the vice president of the International Council of Monuments and Sites, we have an initiative called the University Forum, in which we have universities across the world that are associated to the mission of ICOMOS. And we were thinking of maybe having something international in which we could have students who are also working on postgraduate programs around the world coming here to Ottawa and in exchange with our students. And the topic will be, what are the challenges in education for conservation of historic places. But if you have any other ideas of workshops, of activities, we have basically 18 months to write checks and then finish the money. Because one thing that would happen if we don't finish the money is that NSERC is not going to give it to us. We're like, okay, you have like 50,000 remaining on here, 2020. When it finishes, that's when the plan finishes. Okay, and I think those were my 20 minutes of glory. And I don't know if there are some follow-up questions. I think we're a little bit ahead of time, 3 minutes ahead of time. If they're not, I would like to introduce you to Professor Jeremy Laliberte, who is one of our applicants in the program. And Jeremy is going to be the moderator of panel number 3, or activity number 3.
Thank you. So good morning again. I'm Jeremy Laliberte. I'm from the Department of Mechanical and Aerospace Engineering. And I just wanted to thank Mario and the other co-applicants for allowing me to participate as a co-applicant, because I'm sort of the aeronautical engineer. I'm sort of the odd one out, I guess, in the program. And I've learned a lot, which has been great. And it's been really interesting to work with all the students. So we're going to have, in this next session, we'll hear from 4 of our students reporting on their internship experiences. So they're basically their training experiences with our partners. First, we're going to hear from Jamie Mars, who is working with Lisa Nickel at John Cook & Associates. So I'd like to invite Jamie up to the front for...
Yeah.
She's coming. Oh, perfect.
Like so. All right. This is so stupid. Let's do this presentation. That one. How do you change the view? Okay. Hi, everybody. First off, I'd like to say sorry for having to listen to his voice, but I'll be brief. I'm Lisa. I work for John Cook & Associates. I've worked there for almost 19 years at this point. Basically, we specialize in heritage restoration, on the structural slope or slant. So this presentation is basically going to give you, a couple samples of projects that we've worked on, and then Jamie's going to go into some specific issues that we run into. Generally speaking, the way we're going to run this is there's 3, brief samples of jobs we've done in the last year or so. And the final 2 are Jamie's sort of projects that she worked on a lot with her co-op. So the first one is Canada Four Corners. We finished this one last year, the year before that. Chris Bopney led this with John Cook as a mentor. Basically, we did a lot of masonry restoration. They also reinstated the mansard roof. So we did the structural steel for that roof, and then we're involved with the shoring for some of the major takedowns of masonry and rebuilds. I guess here's a couple of examples. The one on the right is an existing condition where they infilled, there was some wood holding up some brick, and it was just a mishmash structurally. On the right side, you can see the withes of the wall separating. This is the left picture is some of the shoring and the takedown, dismantling of the stone. The next one I want to highlight is the ZB development. That one's ongoing. Pam is in charge of that from our office with, again, John Cook as the mentor and the backup. This one has a lot to do with, basically we did a seismic upgrade here. We repointed a lot of the brick. We did a lot of infill, floor infills, and new, they wanted to bump out some of the walls and put new areas in, so we filled those in structurally. And then just a lot of dealing with existing materials and, how good are they, what's the capacity of them, that sort of thing. There is that photo on the right shows a new atrium in between two of the buildings. So that was, we had two heritage buildings now that are tied together structurally. Postal Station B is the final one. This one we did the heritage masonry restoration on the top of everything above the gutter. We also did a full seismic design for the building, but in the end that got canceled due to funding issues, so that was never actually complete. We also did some reinforcing. There was a lot of structural steel in the building that was rusting or needed a capacity check. And this is William Street. I'll let you take over.
Right, so the next two projects I'm going to talk about are two that I've had the opportunity to work on this summer. I've worked on a bunch of different projects, but the reason why I want to go into these ones specifically is that they've both had situations where you've needed to use your engineering judgment and needed to collaboratively talk with other people in the office because there's questions that can't exactly be solved by math. And so we're hoping that these case studies will inspire further discussions, and also research moving forward into a way that we can actually look at these problems. So the first project is William Street, 35 to 41. So these are a strip of buildings in the market that burnt down or that had a fire earlier this spring. So the interior was basically completely destroyed based on the fire, but the exterior masonry was deemed unsalvageable. So we needed to stabilize the masonry in order for the rest, the demolition and then future reconstruction to occur. So the project that I'm going to talk about is the shoring design of the historic masonry facade, and then also the masonry conservation. So the first question that we came across is, how strong is the existing masonry? There are a bunch of different questions that go into this in a typical building, but for this building specifically, it also experienced a fire. So was there heat damage? We were unsure. And the other thing is that we typically would completely repoint a building so that we are aware that the mortar is in good condition. But due to timelines with this building, the shoring and the repointing kind of happened simultaneously, so we couldn't rely on the full repointed strength of the wall. So basically for the out-of-plane strength for the front facades, we added these two very large W section beams, and then we designed them so that if 20% of the mass of the front facade of the wall was acting laterally, then there would only be a 10 millimeter displacement of the beam. But in that situation, the lateral force from the front facades would then be imposing on the side walls of the structure, so they are technically acting as shear walls in this situation. So we needed to ensure that these walls were also strong enough to handle the load. An added issue that you can kind of see in these two buildings is that there is a vertical construction joint in the middle of these walls that we wanted to act as shear walls. It's more visible in the one on the left because due to the demolition process, we ended up having to take down the top story at that construction joint, but there's also exists in the other wall as well. So to be able to tie these two walls together and make them act as one, we ended up doing a combination of two different designs. We have a steel tie going across the joint anchored, and we also have very large Syntec anchors at midspan or at midway between our steel ties that are kind of cross-stitching across the joint so that these two can act together. So reasonably, based on engineering judgment, yes, these two walls are acting together, but it's more difficult to look at a problem like this and actually do calculations and apply math to it. The second project, or the last project that we're going to talk about today, is the McKay United Church. So this is a church in New Edinburgh near Rideau Hall. And the main project is actually on this front buttress here. So just due to the roof slopes, the bell tower, and you can't really tell, but the main roof as well, it funnels water directly into that corner and it runs down the face of the buttress. So over the last 100 years, and the water has been rushing down it, the core has been totally eaten away. So for this project, we needed to stabilize the bell tower, the buttress, And then we also had a large part of the project was doing water management on the roof and adding flashings and crickets to ensure that the water no longer runs down this buttress. So here the picture on the left is the buttress, and as you can see that the water, in addition to eating up the core, the buttress has also started to separate. And so the gap between the two was approximately 2 inches. So we ended up, as part of the project, completely dismantling one of the buttresses, the top 2/3 of the buttress, so that we could rebuild it tight. But when we were dismantling, it became rather obvious that there was no keystones. These stones, they don't extend into the other buttress, they're very short. And that is typically one of the main ways that you kind of hold a masonry wall together is with these tie stones. So when we were rebuilding, the kind of question came up is how do we make sure that there is that tying action, there is that keying force if we don't have the stones, and we didn't have it in our budget to just buy a whole bunch of new stones that were big enough. So we ended up doing a combination of these helical anchors, which you can see in the image on the right. They're very small and very kind of flexible, but they added just enough of that friction that we felt that in addition to any new stones that we did buy, we bought them to key, and that as a combination would be enough to hold the buttress back to the wall. So in conclusion, it's been a pleasure working at JCal. There's a large variety of projects that I've gotten the opportunity to work on, and it's rather interesting. It's more than just codes and textbooks. A lot of the problems that we come up with, it's a collaborative work environment, and you need to go and talk to your coworkers and learn from their experiences.
We have time. Excuse me. We have time for a couple of quick questions for our next speaker, for either Lisa or Jamie. Oh, one back there, yeah.
So it's currently still half dismantled, but it's overall approximately 3 weeks. It's rather short. Yeah, to take it down and to rebuild it, probably 3 weeks to a month.
And you know that how many anchors they put in?
Yeah, so they put in those 2 anchors at every course. Every course they put 2 in, but the courses are about 350. And then the tie stones, we have them at about on average 6 feet. We had to replace the stone, so we were able to go an additional 6 to 10 inches into the wall with these new stones that we bought.
So the buttress have up to
Buttress is about, the part that we dismantled is about 4 meters.
4 meters.
Yeah.
Thank you.
Thank you. So I'd like to introduce our next speaker, Natalie Smith, who is going to talk to us today about the analysis of timber structures from her internship at the University of Mayo.
Okay, so I'm Natalie Smith. I'm a student with the NSERC Create Heritage Engineering program, and I'm going to be talking about my research internship, which involved understanding and analyzing timber vault structures. So my internship took place at the University of Minho in Guimarães, Portugal, where I was supervised by Professor Jorge Branco and Paulo Lourenço. I researched and reviewed current analysis methods for timber vaults. I also developed a testing proposal for experimental evaluation of a timber structure. And during this presentation, I will also be speaking about my recent experience at the Structural Health Assessment of Timber Structures Conference, which was held at the University of Minho this past September. So part of the scope of work was to understand the different typologies of timber structures that we still see in Portugal and Western Europe. So these types of structures include cruck frame vaults, open trusses, Gothic ribbed vaults, and curved plank vaults. Cruck frames are basically vernacular buildings developed in the Middle Ages, which are used for which use naturally curved heavy timber. They're kind of perfectly imperfect structures. usually joined with traditional joinery like mortise and tenon joints and scarf joints. Some typical issues seen in this type of frames are wood decay and failed connections, which can be reinforced with iron strapping or bolts. We also have open truss vaults, which are just trusses that don't have a tie beam. These were traditionally joined with carpentry joints, but obviously these have evolved a lot over time. So in about the 15th century, we start to see the introduction of iron strapping and metal connections. The main issues with trusses is that there's really large forces at the base, which promote spreading, which can be fixed by installing a tie beam. Ribbed vaults were developed in the Gothic period as an alternative to masonry roofs because they're much lighter and easier to build. The ribs are the primary structural members, which are heavy timber that are joined using traditional joinery methods, and the boards are nailed on and transmit the roof load to the ribs. A lot of the issues in these structures are the high bending stresses in the boards, which can be fixed by installing intermediate ribs in the structure. And then in the Renaissance, we saw the development of curved plank vaults. Curved plank arches are made by overlapping boards and then cutting them into an arch with the desired radius. The arches are then joined to one another laterally with large dowels. These tend to have pretty low bearing stresses and will typically fail at the joints between the planks, which can be fixed by reinforcing with steel side plates or more timber. Some of the analysis methods that I reviewed include in situ, experimental, and theoretical analysis. So in situ analysis is what's done on site, which includes observations and non-destructive testing. These are useful for getting preliminary material properties and a kind of broad understanding of how the structural performs. However, some of the limitations are that experience is required and access to equipment can be difficult, especially if some of these things are expensive. Experimental analysis can be done through destructive testing of either a timber sample, an entire member, or an entire assembly, where it's basically tested to destruction to determine the strengths. However, this is extremely invasive. So laboratory analysis can be done to determine a timber species and then determine the strength values based on existing design codes. I also did some theoretical analysis during my internship, which was predominantly finite element method modeling. For FEM modeling, the model is only as accurate, or the results are only as accurate as the model, so it's really important to get good geometry and material properties, which can be determined from the laser scanning or material testing or design codes. The trickiest thing to model is the joint conditions because very little is known about that. So these can be determined based on other analyses, laboratory testing, or you can apply an upper and lower limit to the stiffness at the joints and conduct two analyses. So the testing proposal that I developed was basically an experimental campaign on a small timber vault. So the vault is two arches that are connected laterally with some nailed decking. The arches are made up of modular planks that are connected using biscuit joiners. It has a 4-meter span based on the lab's capacity and is made of maritime pine, which is the most common type of pine in Portugal. So for the procedure, symmetrical and asymmetrical loading are applied and the deflections are monitored with strain gauges at these key locations. I also made a numerical model to compare with the experimental results. Okay, so now I have a few minutes to talk about the SHADIS conference that I recently attended. So the conference touched on a very wide range of topics. There were also some special sessions on timber constructions in East Asia, as well as seismic resisting frames in the Mediterranean and repairs to historic timber bridges. My presentation touched on my role in the rehabilitation of a historic timber frame mill, which involved condition assessment, material testing, theoretical modeling, and the design of structural interventions. There was also a technical visit at the end of the conference where we visited a historic timber frame house that was undergoing a rehabilitation, as well as some wine cellars in Porto, where we could see different types of historic timber trusses and the different methods of reinforcing these. So I gained a lot of valuable tools from this conference. It was very nice to network with different timber professionals and learn about the state of timber conservation around the world and not just in Canada. And that concludes my presentation.
So time for a few questions.
Yes. In your slide on a finite element model, it appeared that the structure geometry you showed was a semi-spherical dome and a single arch.
Yeah.
But in medieval construction, I don't think they would have ever done that. I think it would have been a vault extending from that arch to the center point of the dome.
Oh, that wasn't a medieval construction. That was like a Renaissance domed structure.
They would have the domes like that were separate from the arches.
Yeah, it was kind of a strange one.
What type of elements did you use? Did you use 4-node linear, 8-node, or 8-node quadratic?
Linear.
Linear shell?
Yeah.
Thank you.
I have a question about the curved light bulbs.
Uh-huh.
I was sort of, I haven't seen them before. It was just
Yeah.
almost like laminated linear
Yeah.
ribs. Were they alternating with grain direction?
I don't think so. It usually went in all into the same direction, but then they cut them to the arch shape, so it would have been like slightly off.
Other questions? Thank you, Natalie. Okay, so our third presenter is Elise Camp, who was also working at the University of Minnesota, who's going to talk about the Heritage Care Project.
Hi everybody, my name is Elise and I was doing an internship this past summer at the University of Minnesota working on the Heritage Care Project that was ongoing there. So the Heritage Care Project is monitoring and preventive conservation of historic and cultural heritage methodology. So it's based on creating a methodology that is digitally based for preventative conservation. It includes standardized and integrated documentation protocols with systematic data collection and classification for risk assessment of the different cultural heritage sites. And it is based on providing an adaptable methodology for a diverse range of building typologies. And for the methodology is for supporting decision-making over the long-term and short-term of heritage sites. So I was located in Guimarães in northern Portugal, although the project is, the scope of the project includes Portugal, Spain, and southwestern France, as you can see here. So this map is showing the density of listed heritage sites in the regions that were involved in the project. So the partners involved in the project are several from each country throughout Spain and Portugal and southwestern France, although the project was coordinated by the University of Minho. The objectives in creating this methodology through heritage care were to provide enhanced tools that were digitally based for preventive conservation and monitoring of heritage sites, as well as providing financially accessible tools for conservation stakeholders, engaging the building owners in the conservation process, as well as providing a methodology that will facilitate sustainable conservation practices. So the outcome of this project has been nonprofit entities in each of the associated countries that are implementing this heritage care methodology. The methodology of heritage care is based on 3 service levels, the standard care, plus care, and then total care. These 3 service levels reflect the quantity and complexity of the data and information that's gathered from the buildings in each of the service levels. So for the standard care service level, this involves a rapid survey of the assessment of the building and reporting the information that's necessary for the primary health and ordinary maintenance of the building. The plus care service level involves the information taken from the first service level, in addition to monitoring of quantitative variables of the building, such as temperature and humidity throughout the building, as well as an assessment of the integrated and movable assets that are throughout the building, and putting all of this information together, again, reporting it to the building owners in an enhanced level of documented information for conservation of the building. Finally, the total care service level takes all of the information from the previous service levels and incorporates it into an HBIM model that is used as, again, an enhanced documentation system for the stakeholders of the heritage building. And all of these service levels are implemented using some tools that were developed through the Heritage Care Project. So these tools include a database, which involves a damage catalog that was developed at the University of Minho, as well as a data storage site for all of the information gathered about the different buildings that will use this methodology. The whole methodology is managed through the website that was created. This website allows for each building that is using the methodology to have their own sort of database of the condition and information of their building. And then a mobile application was also developed through the project that is used during the on-site inspection aspect of the project, so that you can input all of the data that you're collecting through this application and sync it with the mobile or the website, so that then you can manage the information on your own computer. So the methodology was put into practice using a very large number of case studies throughout the different countries. This ended up being 20 different case studies in each country for service level 1, and then about 15 for service level 2, and then 1 service level 3 case study for each country. So what I was doing in the project was helping to put into place 3 of the service level 1 case studies in Portugal. So this is one of the buildings that I was able to work with for service level 1. It's an 11th century cathedral. And then the picture on the left here is a 16th century palace, or part of a palace. And then the picture on the right is a 19th century church in Portugal as well. So these are the 3 buildings that I was working on while I was there. And so for service level 1, it involves 3 phases: the pre-inspection, on-site inspection, and post-inspection phase. So the pre-inspection phase is really the understanding phase, where we're gathering background research regarding the typology of the building, the history of its construction and use, and its cultural values. And then the on-site inspection phase is where the condition assessment actually happens. So that's using the application that was developed to gather all of the damage information, categorizing it and classifying it based on the damage classification system that was developed through the project. And then the post-inspection phase is where the information is all managed and summarized in a report that's given to the building owners in part written document and part damage mapping, so that they have a visual tool to see how their building is doing. So for the condition assessment, the damages are defined based on the classification system that was developed by the University of Minho. It's a very detailed classification system that goes down from class to subclass and sub-subclass. So lichen on a roof like this would be a subclass of biological degradation of the building. And then each damage is given a condition classification between good, fair, poor, and bad. And the extents of the damage are also taken into consideration. So if the lichen on the roof is covering the entire roof or only a portion, it affects how the condition is evaluated. And then finally, the damage is given an urgency or severity classification based on requiring long-term, medium, short-term, or urgent conservation interventions. So the final outcome of this first service level is the owner's report, which involves producing the condition information for the owners. As you can see here, it's a very visual tool for the owners to see the condition of their building. So there's damage mapping, which you can see a little bit of in these areas. It uses a grid for each different damage to specify which damage type is existing in what areas of the building. And then it tells the owner the severity of and extent of the damage and the requirements or the recommendations for conservation interventions, including the recommended timeline for conservation actions and the specific actions that are recommended to take place. So the outcome of this owner's report is that the building owners have a simple tool to visualize the condition of their building. And the report also allows the owners to engage effectively with the conservation practices of their building. And the report facilitates a sustainable conservation method for the long term. So my experience working with the first service level of Heritage Care Project is that this methodology effectively incorporates digital tools into conservation practices. It effectively incorporates a standardized system for classification and documentation, which minimizes the subjectivity of assessing the condition of heritage buildings. I was especially able to see this through the 3 different case studies that I worked with. One of the case studies, the scope of the assessment was very large, and the site inspection actually took 5 days, whereas one of the other case studies took 1 morning. And so the extents of the damage were quite ranging, but using this standardized system for classification and assessing and reporting on the damages in the building, I was able to see to minimize the subjectivity between the 2 cases and produce accurate reports for the owners to see the condition of their building. So that concludes my presentation for today. I just want to thank the University of Minho for allowing me to work on the project with them, and thank you all for listening.
Time for some questions.
I'm curious to know how widespread is this heritage care program working? Is it you showed examples of churches, but is this being used beyond this building?
Yeah, so it's just the methodology has just been published, so it's just being implemented now, and they're setting up nonprofit entities in each of the countries. And so although I only got to work on masonry buildings, the purpose of the methodology is to be able to be applied to any typology of heritage structure to give a fair assessment of its condition. So when in practice, it would be applied to all sorts of heritage structures, not only like the masonry buildings that I was working with.
And what organizations are funding this?
It's a variety of organizations throughout the 3 countries. I believe it's the University of Minho, as well as a university in France and Spain. Sorry, I don't remember the names, and some other heritage-related organizations, non-government organizations.
Thanks.
Yeah.
Could you discuss a little more the method of assessment? Is it basically just visual or superficial, or you're actually making sample of things for investigation with level of access?
So that totally depends. It's a case by case, I guess, example for how much access we're given to assess the building. But the service level 1 assessments are done totally visually. You're using your tablet and going through the building to visually assess for damages. But you're not necessarily given full access to the building. So for example, if you might not have full access to see the entirety of the roof structure or maybe attic spaces. And so it is really quite a rapid survey of the building. If a building is implementing all 3 service levels or even 2, you might be given more access because you are going to be surveying and monitoring for a longer term. For example, service level 2, there's monitoring techniques that use temperature and humidity monitors for maybe several weeks or months at a time. So you might be given more access to assess the building then.
The report looked great. I just wondered, in the highest service level, are you addressing maintenance at all in terms of what you're recommending for the owners? And did you work that into the ask at all?
Yeah, so the maintenance for the building is recommended in each of the service levels. With the highest service level, it's just giving an enhanced tool to visualize the condition of your building. So there's the BIM model, as well as some VR tools that are given to owners to help them understand the condition of their building. But in each of the service levels, recommendations for maintenance are given. And then you can actually also implement that in the app as well. The app is totally a tool for on-site data collection. And so on-site, you can just add a note in the provided space in the app for recommendations.
So is the app for you, or was it for them?
The app is for the conservation inspectors. And then it's synced to the website, which is for the owners to see their reports. Yeah.
There was one more. Yeah.
It's just a clarification about the Heritage Care program, is that in the Netherlands, in France, there is an organization called Women's Watch. And actually, Heritage Care is something based on this. These are two organizations. These are non-for-profit organizations which are supported by the state of the Netherlands and Belgium. And they work in inspection of the equipment, and basically an owner can become a member of this organization, and they are guaranteed an inspection every 3 years. And this allows to have a kind of preventive maintenance program. And this program has been extended to other parts of Europe, like the UK, there is several countries in organizations, Germany, France, Portugal, Spain. So the Heritage Care is part of this network of organizations that actually kind of doing these inspections. But this has been happening for the last, I think Women's Watch has about 30 years history. And another question that you might have is, why do we have two people going to the University of Minho? And I just wanted to bring your attention to Paulo Lorenzo, who was one of our speakers about a year, 2 years, I don't remember exactly. And actually, Paulo is the director of the program, and he was kind enough to provide. And we also have a lot of the students from Carleton that actually go to the SAC, which is the Structure and Historic. Is this program on social analysis of historical social. That's the name of the master's. It's a comprehensive master's for a year and a half for mostly engineers or architects to understand how to interact with historic things. So we have some kind of paper partnership with SAC, so we are able to send some of our students to some of them.
Any other questions? Thank you very much. So I'd like to introduce our final speaker for this session, Kristen Upyar, who's going to talk today, provide an update on his research on masonry structures.
Yes. Those of you who were at the National Trust Conference, this might seem familiar. This is a final update on my research studying the effect of adding casein protein to historic lime mortar. First, for those of you who are new to this and who weren't here at last year's seminar, this is an example of casein protein from an internet image that I had pulled at the right. That is what the pure powder looks like by itself. If you want to see it in real, I could get a sample from the structures lab at lunch. It is a milk extract that is mixed, where skimmed milk is mixed with acid to produce it. While this had been known to have been used in medieval times, I found this from a study in Italy confirming by performing a chemical analysis that this protein was used, and a 1703 book reference that described a mortar mix where adding lime and sand to skimmed milk was called for in the procedure. And it was because of the casein protein that the recipe called for this. Throughout the 19th century, casein was also used in various glues and adhesives and is still used today in some specialty paints. Why did they use it in mortar, however, you might be wondering? This was mainly for a flow or workability reasons. And you will get a grout-like pourable consistency when you put in 0.5% casein by mass. A lower percentage than that is not sufficient to enable a flowable grout-like mortar, and more casein than that will mean it will not set properly. However, I could not find any research on what this protein did structurally, other than the one study that I have cited on the slide, and they tested only 0.1% by mass and showing a slight decline in compressive strength and by a 10% and a marginal 10% increase in bending. But from my own tests, 0.1% casein was deemed not sufficient to improve the flow properties. So here were the 4 mortar prism tests that I conducted. Compression is at the top left, tension at the top right, using what is called the double K method. Based on the original design of those brackets, consisted of a plate and an angle bar to look like 2 miniature Ks. The method in which the tension test at the top right works is identical to that of a split cylinder, whereas the vertical cross-sectional diameter would represent the same distance as that from the top vertex to the bottom vertex. And it is through the split cylinder ratio that specimen will break through a vertical crack in the middle, and from that we can determine what the tensile stress is. Flexural test was done using a 3-foot bending as shown at the bottom left of the screen, and finally the shear test was a direct shear prism at the bottom right. The flexural test specimen measured 40 millimeters by 40 millimeters by 160 millimeters, whereas the compression and tension tests were 50 millimeter cubes in all dimensions. So here we see what happened with casein in compression. The graph at the left shows what happens as the casein content is increased. While this is not a standard way of showing mortar hardening curves, I provided that to indicate the almost 75% strength reduction that you would see when you add 0.5% by mass, as shown here. Even with 0.1% to compare with that other report, I also tested, and I got anywhere from a 25 to 40% reduction and a 50% reduction at 0.25% casein. Thereby, in fact, you will get a strength reduction before getting the flowable properties that you would want to have casein for. So, in other words, if you want flowability, you have to take a trade-off of material strength when using this. And here is your more typical strength curves that you would see, where I tested up to 112 days. And at this point, the strength would harden. However, the ratio reductions, due to my limited sample size, there is a large variance in this. However, it is relatively constant. For instance, the blue line, which is 0.5% casein, still is only approximately a quarter of the strength of the black line, which is no casein. Then I looked at tension. Similar to compression, I got almost the exact same pattern. Again, with the same sort of graphs. The 0.5% casein was the point at which it was of flowable properties, and we had a substantial strength reduction by about 70% in the tension case. The flexural bending test, which the other one showed us ever so slight improvement with the low casein. I, however, did not find this. And even up to 112 days, I saw the same 70 to 75% strength reduction at 0.5% casein using the 3-point bending test. Then in shear, the final test case of the 4, the same result again. It might leave you thinking, now, the other thing I looked at was what would happen with holding the casein content at 0.5% and reducing the water content. Would that be the optimal mix? This 1703 reference that I indicated actually called for a very low water ratio. It called for equal parts of lime and sand, and what I worked out to be approximately 3.5 liters of water for every 30 kilograms of mortar, which is less than what the premixes of today use. So I tested that. Reducing the water to 3.5 liters per 30 kilograms at that ratio, you would get, based on the original, if you look at the original strength of 4 megapascals for 0 casein, we see the same sort of results at 3.5 liters of water, but that is not flowable. One, it will not produce a flowable mortar. Number two, it cures in less mortar mix, thereby rendering it unusable for most applications. And you don't get proper bonding or curing of the specimens at that point. I found that 4.4 liters of water was required to give you a flowable case. And at that point, you'll observe an almost 40% reduction below the original baseline that had no casein and the standard 5.5 liters of water per 30 kilograms. So when reducing the water, you do get some of the strength back. And it appeared qualitatively based on mixing and flow recordings that I did as a sample, that 4.5 liters of water, or an 18% reduction in the water content, would yield the optimal case when you mix at 0.5% casein by mass. Again, when I test compression, tension, flexure, and shear, the results are, in terms of ratio, are similar across the board, with the strengths in megapascals adjusting based on the case tested. At this point, it would seem structurally that casein is absolutely useless if you look at material strength alone. However, the final test I wanted to do to see if this would change anything is bond testing. And for most of you, this is likely new, when I added casein and tested brick to mortar bond, the strength improved at this point. This was 0.5. I only tested the bond strength at 56 days. However, the no casein bricks would break away very easily. Whereas if you had 0.5% casein by mass, it in fact had a higher bond strength of 0.15 megapascals. In fact, the prism strength at 0.5 megapascals was approximately 0.1 megapascals. This 0.5% casein, the prism strength and tension was about 0.1 megapascals, thereby signifying that it is in fact the tensile strength of the material that governs over the bond strength. And while I don't have that in my slides, I found that in many cases when I tested them, the mortar joint would fracture along the midline of the brick. When I tested 0.5% casein, we would see the fracture happen in the middle of the joint and not at the brick to mortar interface. That would confirm my assumption that the tensile strength governed over bond strength. And the testing shear bond here, where I pushed down, where I had the test machine push down on the center brick, while these two bricks on either side were fixed in place. I recorded the force at breakage and divided it by twice the cross-sectional area of these bricks, which would then allow me to determine the shear stress in the joint at failure. And again, when I added the casing, the bond strength substantially increased. And if we compare this again, it was higher in some cases. If we look at 0.5% casing here, it was 0.1 megapascal in shear at 56 days. Whereas it was 0.14% in bonding. And once again, I got the failure pattern of the mortar joint failing in the middle and not at the brick to mortar interface. So I also conducted flow table testing of each batch as I cast them, based on the CSA and ASTM standards, and which involved oscillating the table 25 times in 15 seconds, or as close as I could get it with a manually hand cranked table. And then that was a medium casein content specimen. The yellow arrows, as I've drawn them on the map, which indicate these measurements, which I would take with a ruler in millimeters, as I did not have access to the specialized caliper that normally comes with these tables, or the department had long lost that tool if they ever had it. However, I would record that in millimeters versus the 99 millimeter diameter of the initial cone at starting, and determine the change in diameter that way. Some of the high casein content, where we were looking at 0.5% casein and 5.5 liters of water, would actually overrun the table completely, in which that was what I had denoted. We would never design an actual mortar mix to do that. However, for the purposes of testing and keeping a consistent comparison, I needed to do that for the purposes of my thesis. Whereas by having this, we found that casein would be beneficial in a retrofit scenario, whereas you may have two Ys of masonry where you need to inject mortar to consolidate in between the Ys. In this case, it would provide an adhesive bond strength to prevent the different Ys of mortar from moving apart in light load situations. I also found that when casein is added to the mix, it reduces the amount of water that needs to be added while maintaining the pourable consistency. Unfortunately, masonry work is still an art. In fact, adjusting the water content was something I had never planned to have to do until later on, where I had to look at that variable to figure out what was the proper amount of water to use in the given case. And it's still, to this day, none of the international mortar standards, CSA, ASTM, even EN standards, do not list the amount of water that you would put into a mortar mix for a given type. They only list lime, sand, cement, and for specialty types, fly ash, or other components. So something which I worked on after my thesis, this is the last was type S mortar. Just a plain old type S mortar with casein added. The problem thing is, normally this is too strong to use on a masonry repair, as it would cause cracking of the brick. But given what casein did to lime mortar, I'm wondering if it would in fact reduce the type S mortar such that it is appropriate in a historic building. I also had to adjust the water content down to 4 liters of water, or in the later 3.5 liters of water per 30 kilograms. And I found that the 112-day strength in compression was 5 megapascals with 0.5% casein, which is the range of what a natural hydraulic lime mortar would provide by itself. That concludes my presentation. If there are any questions.
We have time for a few questions before we go into our coffee break. Questions for Christian?
Yes. Given that there are like latex or polymer additives that you can add to groundwood mortar, why would you want to use casein instead?
Yes, while the number of additives are limitless, there may be also issues with supply and environmental concerns, because the casein protein is non-toxic and has no negative environmental health impacts, whereas latex admixtures, which, while they may be easier to use and more defined, are proprietary mixes that may go out of production, and it may not be possible to recreate as easily as a naturally produced protein that has been in production for 500 years. Yes?
At the microscopic level, has there been research done that can explain how the addition of casein changes like the pore structure or to give it those ideal properties?
I haven't found that. I did find that it increased the air entrainment of the mortar specimen. But however, due to the limited lab equipment, all I could do was measure the mass of equivalent volume prisms. And I just noticed that the density had decreased whenever casein was added. But I didn't have the tools to measure the exact air entrainment either. That would be an interesting study that I would have liked to have done had I have had the equipment available.
Any other questions? Thank you, Christian. So I just want to thank all the students, the speakers again. We have a short coffee break until 10:45, so we're running a few minutes ahead. That's all right. There's time for some networking and catching up. So when you refill your coffees and then grab some refreshments, and then we'll have Mr. Liam O'Brien, who's going to take over and moderate the second half. Thank you.
So if you're in the second session as a presenter, make sure that you have your presentation on.
Sorry, I didn't know you were finished talking.
Oh, that's okay.
And I was like,
Oh, you did?
For German? Hello. So do you have a fellow presenter?
Do I have a what? Sorry?
Is someone else presenting with you?
Yeah.
Josh or
No,
Julian?
it's neither of those two people. It's Phil Richard.
Yeah.
Yeah.
Wow.
Yeah. Have you met him before?
Yeah.
Yeah.
Sorry.
Yeah, I can't see.
We met at the BIPSA thing.
Okay.